All right, so the next section we want to take a look at here, section 21.3, very specifically is going to be the equation of a circle. All right, so in generic form, the standard form of the equation of a circle is given by x minus h quantity squared plus y minus k quantity squared equal to r squared. All right, so given in this standard form, hk gives me the center of my circle, and r gives the radius of the circle. All right, so for each of the following examples, we want to give the center and the radius for the circle. So number one, I have x squared plus y squared equal to 49. So if I'm not adding or subtracting anything off of my x values here, or off of my x squared values, I can see that my circle is going to be centered at the origin. So very straightforward here. If you have x squared plus y squared equal to r squared, this is a circle centered at the origin. So this is a circle with the center at the point 0, 0. The center is at the origin, and the radius is equal to simply just r. All right, so this is a case like that. If you had to write it in this standard form, we would give it as x minus 0 squared plus y minus 0 squared equal to 49 can be written as 7 squared. And so from this, we can very simply then just pull out h here is 0, k is 0, and r is 7. So again here, the center is at the point 0, 0, and the radius is equal to 7. All right, example number 2. We have x plus 1 quantity squared plus y minus 4 quantity squared equal to 25. So the problem that I see here is that in the standard form of the equation of a circle, this sign right here is a minus. Right? So if I want to be able to just simply read off h and k, I need for these signs to match the standard form. So I'm going to force the sign. I'm going to write this as x minus negative 1 quantity squared plus y minus 4 quantity squared equals 5 quantity squared. All right, and so now we see that what represents h here is this entire term, negative 1. This is h. All right, k here is just 4, and then r is equal to 5. So the center of the circle will be at the point negative 1 comma 4, and then the radius of the circle will be equal to 5. All right, example number 3 here. X squared plus y plus 9 squared is equal to 8. So again, if I try to replicate this standard form, I will have x minus 0 squared plus y minus negative 9 quantity squared equal to, so is there a way for me to write 8 as a quantity squared? Square root, right? So I'm going to give this as the square root of 8 quantity squared. All right, and so again, this now matches. We can kind of put this side by side with that standard form. And this right here forms h. Everything in here is equal to k, and everything in here is equal to my r, right? It kind of has that structure. So the center of this circle will be at the point 0 comma negative 9, and the radius will be equal to the square root of 8. All right, so these examples that we just gave you guys here are already given in fairly nice factored form. All right, so oftentimes when we deal with examples like this, we are going to see the equation of a circle given in general form. All right, general form. So that is x squared plus y squared plus dx plus ey plus f equal to 0. So really, actually, before I jump into this, again, a quick little review item here. Do you all remember anything about completing the square? All right, let's quickly take a step back here. Let me quickly remind you of something that you had learned, I don't know, some semester, some year prior to this. All right, if I ask you to factor x squared plus x minus 6. All right, there's a polynomial. Can you factor? What would this factor into? It would factor into x. It'll be, I think it'll be the other way around because this is positive, right? So it'll be x plus 3, x minus 2, right? You guys agree? All right, so we remember how to factor a quadratic, right? How about x squared plus 8x plus 16? How does this guy factor? So what is it that we ask ourselves when we factor a polynomial like this? It's going to be x plus 4 squared, right? So we want to know, so before we arrive at that, let's put in this extra step. So because I'm dealing with x squared, I know that this will be x and x. So what I'm asking myself is I'm looking for a set of numbers here such that when I multiply them together, they need to be equal to 16. When I add them together, they need to be equal to 8. Right? So this becomes plus 4 plus 4. So we can further simplify and just say this is x plus 4 quantity squared. So when does this occur? This is really nice. We call this guy a perfect square. Right? When does a perfect square occur? What is the quality that you look for here? What has to happen? All right, so generically we say ax squared plus bx plus c. This is how we sort of generically represent a quadratic function, right? So this is what happens. If you take the value, the number that is in place of b, right? In this case, it's 8. Divided by 2. 8 divided by 2 is 4. What is 4 squared? 16. So when that happens, we are going to get a perfect square. So sometimes it happens that I don't have a perfect square, but I really, really want one, right? And so we fudge a little bit. So here's another example. X squared plus, let's say, 10x plus 20. Is this a perfect square? It is not. What number would I, so in this little box right here, what number did I really need there to have a perfect square? 25. So I don't have 25. But here's what I'm going to do. I'm going to add 5 and subtract 5 from this equation. Is that legal? That's absolutely fine. So I can rewrite this as x squared plus 10x plus 25. I'm just going to leave the minus 5 out there. Now, what I see over here, this can factor into a perfect square, right? So this will become x plus 5 quantity squared. And then we're just kind of stuck with this negative 5 out there, right? Not ideal, but we'll worry about that later. For now, the idea that I want to get across is that you can add a number, subtract it right off in order to, or you can rewrite 20 is the same thing as 25 minus 5, right? So we can sort of restructure our expression so that we can get a perfect square out of it. All right, so back to that in just a little bit. All right, here's an example. I have the following circle. X squared plus y squared plus 8x plus 4y plus 16 is equal to 0. So here's what I'm going to do. To start with, I know that this is a circle, all right, because I have x squared plus y squared. What I'm going to do is I'm going to group like terms together. I'm going to say I have here x squared plus 8x. I'm going to group the y terms together, so I have plus y squared plus 4y. And I'm going to group the constants together, and typically I'm just going to move them over to the other side. So the 16 is going to go over to the other side of the equation and become negative 16. Okay, I know I left these like odd little spaces. I'm leaving room for something. I just kind of sort of group things together. So now what I want to come back to here is this. For x squared plus 8x plus some number to become a perfect square, what is the constant value that I would need here next to this quadratic? 16. So I'm going to add 16 here. And that is legal if I add 16 here, as long as I add 16 to the other side of the equation, right? Just keep your equation balanced. All right? Similarly, what is the value, what is the constant that I need right here? Y squared plus 4y plus 4, right? So half of 4 is 2, squared is plus 4. So I'm going to add a 4 here. That's okay, as long as I add 4 to the other side. So either I can subtract 4 from this side or add 4 to the other side. Those are equivalent actions. But so now all of this together becomes a perfect square. X squared plus 8x plus 16 is equal to x plus 4 quantity squared. These guys can be grouped together. Y squared plus 4y plus 4 becomes y plus 2 quantity squared. And this is equal to, what do we have on the other side? Negative 16 plus 16 plus 4. So I'm just left with a 4 here, right? We just have 4 on the other side. So now this starts kind of to take on more of that circle equation look. All right, one more thing though, is that I would need for that standard equation, the x minus h squared plus y minus k squared equal to r squared, I need a minus in here, right? So I'm going to write this as x minus negative 4 quantity squared plus y minus negative 2 quantity squared equals 2 quantity squared. All right, so hk here is represented by negative 4, negative 2, so that becomes the center of my circle, the point negative 4 comma negative 2, and then we can say the radius of the circle is equal to 2. All right, the next example, number 5. We have x squared plus y squared minus 6y minus 7 equal to 0. So again, I'm going to kind of group like terms together like I did before. So I have x squared. There's no other term containing x. So x squared is by himself. That's okay. So I will have plus y squared minus 6y, and then equal to, this constant's going to move to the other side. That'll become plus 7 if I move it to the other side of the equation. All right, but now I'm going to come back and see, I have y squared minus 6y. For this to become a perfect square, what is the constant that I need? So half of negative 6 is negative 3. Negative 3 squared is 9. So plus 9. I'm going to add 9 to each side of this equation. All right, so I can group these guys together. All right, x is just by himself. He's already factored. There's nothing to factor. So this is just x squared plus. This guy will factor into y minus 3. Quantity squared equals 7 plus 9 is equal to 16. And 16, of course, can be written as 4 quantity squared. All right, so where's your center at for this circle? The center is at the point 0, 3. And the radius here will be equal to 4.